A point mass m is at a distance r from the center of the Earth. Write down an expression in terms of m, r, the Earth mass me, and the gravitational constant g for the gravitational potential energy V of the mass. Consider only values of r greater than the Earth's radius. Gravitational potential energy is given by minus gm em divided by r. Certain meteorites found on Earth have a composition identical with that of lunar granite. It is thought that they may be debris from a volcanic eruption on the Moon. Figure 6, which is not to scale, shows how the gravitational potential between the surface of the Moon and the surface of the Earth varies along the line of centers. At a point P, the gravitational potential is a maximum. State how the resultant gravitational force on the tektite at any point between the Moon and the Earth could be deduced from figure 6. So F equals to minus dV dr, so it's also equal to m d phi dr, where phi is the gravitational potential. The resultant force at any point is given by the product of the mass and gradient to the tangent of the potential versus distance graph. So for figure 6, a positive gradient represents a negative force, which means the force points towards the center of the Moon. When a tektite is at P, the gravitational forces on it due to Moon and Earth are Fm and Fe respectively. State the relation which applies between Fm and Fe. Hence, find the values of x over y, where x and y are the distances of P from the center of the Moon and the center of the Earth respectively. So at this point, the force of the Moon is equal to the force of the Earth. Because at P, the gradient is 0, so the net force is 0. So the pull of the Moon must be equal to the pull of the Earth. So what we have will be gm Moon times m divided by x squared equal to gm Earth times m divided by y squared. Rearranging the term, we'll get x over y to be 0.111. This is a ratio, so there's no units. If a tektite is to reach the Earth, it must be projected from the volcano on the Moon with a certain minimum speed v0. Making use of appropriate values from figure 6, find this speed. Explain your reasoning. In order to reach the Earth, the tektite has to reach P. Beyond that, the Earth's gravity will pull it towards the Earth. So that means as soon as the tektite reaches P and beyond, the Earth will start to pull it towards the Earth. Based on the principle of conservation of energy, Ke plus P on the Moon's surface must be equal to Ke plus Pe at point P. So what we have will be half mv squared plus minus 3.9 10 to the power 6 m. So that is the potential energy on the surface of the Moon. So at point P, the kinetic energy is 0, and the potential is minus 1.3 times 10 to the power 6 potential energy multiplied by m. So V naught will be equal to 2.28 times 10 to the power 3 meter per second. Discuss very briefly whether a tektite will reach the Earth's surface with a speed less than, equal to, or greater than the speed of projection. The tektite will reach Earth with a speed greater than the projection speed from the Moon because the gravitational potential on the surface of the Earth is lower than that on the surface of the Moon. The loss in gravitational potential energy as a tektite approaches the Earth is converted into kinetic energy.